Today, we look at perimeter, which is, how would you define perimeter? I would start it off with the length of all the sides. Now, yeah, okay, there's a couple of different ways to say it, isn't it, right? You could say the length of all the sides of a shape. The length of all the sides of, so for instance, let's think about some of the shapes we know. Let's go for a square. Yeah, I'll get to the circle in a second. Okay. So draw for me a little square. Doesn't have to be huge. Okay. Here's a square. Okay. Now, we'll get to the circle in a second. Don't forget, what is it that makes a square a square? All the sides are equal, but there's got to be more than that because I can have a shape with all four sides equal, but not a square. And there's something about the angles is important.
Right angles.
They're all right angles. So if you like, a square is a rectangle and a rhombus at the same time. Say that again. A square is a rectangle who's got all those right angles, right? But all the sides are equal, like a rhombus. So if you've got both at the same time, that's what gives you a square. So I think they generally call the side lengths, something like, say, S for side, okay? And you can see those dashes are what indicates they're all the same, okay? So what's the perimeter, P, of this shape? There are four sides, right? So it's going to be?
P.
Yeah, okay. I'm going to put the 4 at the front. We generally put the number at the front. 4S, just 4S. Yeah, 4 times S. 4 lots of S. Okay. Now, that works. The length of all the sides of a shape. That's fine, okay? We could do another similar kind of polygon, the rectangle which we just mentioned, right? The rectangle is different because they're not all equal to each other, so it's just a little bit different. Just draw for yourself a little rectangle here. Okay, now, what do we usually call the two different pairs of sides? We usually call them names.
Parallel lines.
They are all parallel. I sort of talking about, I called these all S. What do we tend to call these? I don't know. We usually call one of them L. I call this one L, right? What do we call the other one usually? Now, you can either have W for width, right? Or you might also see B for breadth. Now, I always got confused as to which one is which. In some sense, it doesn't matter. But I think of B, breadth, as in broad. So it's like someone's broad-shouldered, which is how far across they are. Anyway. Where?
L,
that's an L. Yeah, it's an L. I make it wiggly because if I did my L like that, you can't tell if it's 1 or not. So that's how I make it. You mean like a capital L? Oh, yeah, I suppose you could. It's kind of a tradition or a convention that they do these little things. All right, now this is a rectangle, right? So the opposite sides, as I've marked them in, they're equal. The opposite sides are equal. So that makes this one over here L, right?
Yes.
And it makes this one up here also W or B. Okay? So if the perimeter is the length of all the sides of a shape, then I can say the perimeter is equal to 2 lots of the length, double the length. Okay? So 2L, because there's 2 of them on each side, right? And 2 of the width, right? Now, do you remember back to algebra earlier in the year? This thing we can factorize. You don't have to, but it's kind of neat because you've got 2 twice. So rather than write it twice, you can just say 2. Now how do we factorize it out? What's going to be left in the middle? It will just be length plus the width. Okay, so you can see how that 2 is sort of a shortcut for saying it twice. Okay, that's what the brackets was for. Okay, now this is great. Perimeter is the length of all the sides of shape. It works here. Okay, but there's a shape where it breaks down. And I didn't ask you to bring a compass or anything, but see how well you can draw for yourself a circle. Okay, so that'll have to do. Okay, so a circle, the problem with this definition, which has been pretty good so far, and it's a nice way to think about it, is that a circle has a center, and it has a circumference, but it doesn't have sides, right? Yeah, it's got a radius. So let's draw that in because that's actually kind of important. A radius is the distance from the center to any point of the circumference. In fact, that's what makes it a circle. Makes a circle a circle. That the distance wherever you measure it will always be the same. Okay?
We should have done this on Pi Day.
Yeah, we could have. We went up to it though, which is a bit sad. Yeah, pretty cool. All right, now being that there are no sides, it's not like I can say, oh, look at this bit and add it to this bit and this bit and this bit. Because you'll be doing it forever. It's not like, oh, there's 4 or 5 or even 5 million. There are no sides. Okay? So we'll need a better definition than this. Perimeter is not just the length of all the sides of a shape. Okay? I think another sort of helpful definition for this is perimeter is the length around a shape. Okay? I like both of these definitions, but I think the second one is a little more helpful to us, okay? Because it's still saying the same things here. How far is the length around this shape? Well, you just go all the way around. The same with this. But it works here. Where even when you don't have sides, it works. You can just go all the way around. Okay? So the perimeter here, we said it gets a special name. It's the circumference. Okay? You can call it C for circumference. Does anyone know what the circumference of a circle is? Whoa. Now, don't forget we're talking about lengths here, not angles, right? This angle here, around there, we were looking at angles before. That's 360 degrees. But that's an angle. That's like how far you turn, right? But I want a length around the edge, right?
160 centimeters.
Now, it kind of depends on how big it is, right? Yeah, Christian. Okay, now the answer is it's 2 pi r, but what does that mean? Okay, well, pi is a number. Pi is a number, 3.1415, etc. Okay. So you go 2 times that number, and then if you multiply by the radius, that'll give you the distance around. Okay. Wonder why that is. The radius is always about 6 times smaller than the circumference. And you can prove it by measuring if you like. You get a piece of string and you go around. Okay. But this formula is just what I wanted to remind you of. Okay? I can show you some worse ones if you like, but I won't. One last thing. Yeah, question?
I don't understand the pi angle.
Yeah, okay, sure. Alright. Well, here's an experiment for you, okay? Your circles, right, are all, I assume, different sizes, and they're different to mine, and I could draw a whole bunch of different circles. You know, I could draw another one that's smaller. I could do one that's bigger. Oh, I missed it totally. You get the idea. It looks like more of an egg, actually. I could do a whole bunch of different circles. Okay? Now, my first one was the best. I'm suggesting, right? I mean, you can kind of see, as a circle gets bigger, the circumference and the radius also both get bigger. And they both get bigger with it. So, for instance, here's my radius here. There's like a little small radius there. In the same way, there's a sort of small circumference, okay? And it gets bigger, and then bigger, and then bigger. They both get bigger together, okay? Now, how can we try and get, how close they are to each other as one gets bigger and the other gets bigger? Well, you can measure. You can actually get a rule out. You can say, well, what's this radius here? I mean, what does it look like, actually? Yeah, about 15, I'd say, okay? And then you can get a piece of string, you can stretch it all the way around, and you can see what you get. You'd get about 90 centimeters, a bit over, okay? If you, made a string out there, cut it, and then laid it out straight, and then put that next to a ruler. Probably not this one because it's super gross and dirty. I don't even know how it got that dirty, but anyway. Okay? But that's how you do it. That's because it's been down there for months or something, right? Okay, now you can do the same thing with all of them, right? You could say, well, okay, what's the radius of this thing? Measure it. I know that looks more like 10. Okay, and then take this thing, cut it off, and then lay it out straight and see what you get. Okay, each time you can do it over and over again. You're going to get the circumference about 6.3 times bigger than the radius every single time, no matter how big your circle is. Okay, or how small. Well, 6.28 to something or other. Or maybe 6.283. So it's sort of just a result that we get from measuring these and seeing. That's the number that we pick for that ratio, the relationship between that round length, and that straight line.
It's always going to be the same result.
Yeah, every single time, no matter how big or small the circle is, which is kind of weird and perplexing, but it's true. It's true. At least it's easy to remember. Did you have a question?
So to find the circumference, you do 2 times pi times whatever that line is.
So that's actually how I was doing it mentally. So for instance, suppose you did measure this, and straight lines are really easy to measure, right? And suppose we did measure it to be 15 centimeters. If you then wanted to know what the circumference was without doing the cut out string straight thing that I talked about, you can say, well, the circumference will be 2 times pi times 15 centimeters, which, just to tell you what the actual number is,
Oh, Frank.
30. The only problem with this is that I don't know where the buttons are.
I see.
No, this one doesn't help me because it actually just says 30 pi, which is not very helpful. Someone got a calculator? Nathan, you have a question?
Why do we times pi?
Yes, that's a good question. And the reason why, so let me just write down this number. I get 94.2. Okay. Remember what I said before about experimenting. Right? Yeah, cool, same result. About taking a whole bunch of circles and actually drawing them up and putting the string around them, which I hope your year 7 teachers actually did with you once upon a time. Okay? You can draw up a table for yourself. Like this. It will probably look something like this. Let me get rid of this small circle. You'd go, okay, measure the radius. What do you get? Right? Measure the circumference. What do you get? And then you'd say, well, okay, let's just see, is there a relationship between them? Let's divide one by the other. Okay? You get, 94.2. Sorry, other way around. 94.2 and 15. I wonder what happens when you divide. You do another circle, right? You go, okay, one with radius 10, and you get about 63 when you measure. You're like, I wonder what I'll get. The number that you keep getting is 2 times pi, which seems like it's a weird coincidence to have. They say when something happens once, it happens twice in a row, it's a bit of a coincidence. But if you can do this a million times and you keep getting the same number, it's not a coincidence anymore. It's a pattern. Yeah.
Can I please go to the bathroom?